Hi. In this video, we will go over the exercise problems part of the motion chapter. And to make it easier, I have actually solved them. And we will go over the steps for each problem one by one. So, go the first one. So the first problem is, an athlete completes one round of circular track of diameter 200 meters in 40 seconds. What would be the distance covered and the displacement at the end of 2 minutes 20 seconds, right? So the so we know that it's a circular track. So let's consider the person starts here. So let's consider this to be the origin, and the athlete completes a track like this, right? He keeps completing more laps, right? So the diameter is going to be 200 meters, which means that the radius is 100 meters, and the circumference of one lap, right? The distance or the distance traveled, distance covered in the distance covered in one lap is going to be 2 pi r, which is going to be 200 pi. Let's not expand this one now. And which means that the distance covered in 40 seconds, because he takes to complete one round, the athlete takes 40 seconds. So which means the athlete covers 205 meters in 40 seconds. Which means that in 1 second the athlete covers 5 pi meters, right? And the first part of the question is what is the distance covered and the displacement at the end of 2 minutes 20 seconds. So 2 minutes 20 seconds means it's 140 seconds. So which means the distance covered in 140 seconds is going to be 140 times the distance covered in 1 second, which is 5 pi. So the distance covered in 140 seconds is going to be 700 pi. So the first part of the question is answered here. Now what is the total displacement, right? Now, what the athlete is doing is he's actually making rounds after round, right? He's completing one lap after the other. And we know that one lap is going to be 200 pi, right? Is of length 200 pi meters. So, in the overall distance that the athlete has covered, there are actually 3 rounds that he has done, right? Because 200 pi is one round. So, 600 pi, he has completed 3 complete rounds, which means that after completing each round, your displacement will be 0 because he's coming back to the same point, right? So all what we need to do to find the total displacement is what is left out, right? Which is going to be 100 pi, right? So what is 100 pi? If you really observe this, 100 pi is half of the circumference of the circle. So which means that after 140 seconds, the athlete has actually covered 3 complete rounds and he has actually come to this point B. Right, let's call it point B. Right, he's actually come to this particular point B, and this distance is what is 100 pi. This curve, this hemisphere, the circumference here is what is called is 100 pi, which means that the athlete has actually covered the length of the diameter. That is your displacement, right? That is the change in position, which is equal to 200 meters here. So let's go on to the next one. Joseph jogs from one end A to another end B of the straight 300-meter road in 2 minutes 30 seconds, and then turns around and jogs 100 meters back to a point C in another 1 minute. What are Joseph's average speed and velocities in jogging from A to B and from A to C? So let's pictorially put that here. Joseph, let's call this point as A and B. So Joseph run from A to B, which is going to be 300 meters, and he has taken 2 minutes 30 seconds, so which is going to be 150 seconds. Now Joseph he turns around, which means that he comes back from B to a point C, and the distance there is 100 meters, and he has taken 1 minute here, right? Now what's going to be the average speed between A and B? The average speed between A and B is going to be the distance covered by time taken, which is 300 over 150, which is 2 meters per second. And what is the average velocity between A and B? Because it is a straight path, right? So the total distance is also 300 meters. The total displacement is also 300 meters between A and B. And the time taken is also 2.5 minutes, which is 150. So the velocity is also 2 meters per second. But what about between A and C? Right. So between A and C, the average speed is the total distance that is covered, which is the distance between A and B plus the distance between B and C, which is 300 plus 100, and the total time, which is going to be 150 seconds plus 60 seconds, which is going to be 210 seconds. So the the average speed is going to be 40 over 21 meters per second. Similarly, for the velocity, if you see here, its velocity between A and C is going to be the total displacement between A and C. Now, the total displacement is just a change in position, which is just 300 minus 100, which is going to be 200. And the total time taken. The total time is still 150 plus 100, right? 150 plus 60 minutes, 60 seconds. So it is going to be 210 seconds. So your average velocity between A and C is 200 over 210, which is 20 over 21 meters per second. So let's go to the third one. Yeah. So Abdul, while traveling to school, computes the average speed for his trip to be 20 kilometers per second. On his return trip along the same road, there is less traffic and the average speed is 30 kilometers per hour. What is the average speed for Abdul's trip? So basically, Abdul travels the same distance in morning and in the evening, but the speed is different because of the traffic, right? In the morning the speed is lower, while in the evening the speed is higher here, right? So that's the only difference. So which means that the distance is the same. We have to it's not mentioned that he takes a different route. So the distance is going to be so we'll assume that the distance is the same in the morning trip as well as in the evening trip. Which means that the distance traveled over the time taken is 20. The speed is 20 in the morning, which means that the distance traveled, which is S, over the time that he normally takes. If we take it as T1, that speed is 20. And on the evening, the same thing, the same distance, but he takes a different time because the speed is different. So we can take that, the S over T2 is actually 30. Right? So T1 is the time that he takes in the morning, and T2 is the time that he takes in the evening. So what is the average average speed between considering both morning and the evening, which is the total distance? We know that the total distance is 2s, because he travels one direction. If he travels S meters or S kilometers, he comes back the same distance, right? So the total distance is 2s. And the time taken is T1 plus T2. Right? So this is the time that he or she takes. And how do we solve for this? So from this equation, we know that T1 is equal to, we can bring T1 here, and T1 becomes S over 20, and T2 becomes S over 30. And adding these two, T1 plus T2 gets you to S over 12. Right? If you add these two equations, you get T1 plus T2 as S over 12. And if you replace T1 plus T2 with S over 12, what you get is the average speed of 24 meters per second. So this is your average speed.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.